Today we are going to talk on the linked list data structures. In the last session, we discussed data structure part of the list. So list data structures where we launch uh, all the elements are stored in the form of array. They are take a contiguous memory allocation to add element. Okay, so this is known as a you can say contiguous memory allocation data structures in the form of you can say whatever the data structure we learn array, we learn list. So both are implemented as a array basic data structure in the Python. You can talk list or array, both are implemented in the form of array. So array is the contiguous memory allocation. That means whenever we are going to create one list, the array, they need a contiguous memory of the block, maybe 5 blocks, 6 blocks, 10 blocks, and the value are going to the placed inside. Now today we are going to learn the linked list data structure. So here we are not going to allocate memory for the size of array like a 5, a 10, a 20. So here just allocate memory for one element and store. Whatever the let us example. So if we have this is the our memory space we have. So memory have space have a chunk of blocks. Okay, chunks of block. Okay, each block contains some data. Right. So generally, in the case of array, we need the contiguous allocation blocks should be available here, right? But in the case of linked list, maybe one element is stored here, another element is stored maybe here, another element may be stored here. Depend upon the available space. So linked lists are going to allocate memory for just only one block in the memory space. Where is the space available and how? Let's see, we have add the couple of elements. So any place, whatever the memory space available, these elements allocated, and how we are ensuring that what is my next element. There is a concept of the link. This first node know which is the my next node. Next node know which is the my next node. So this is the way we make a link between the elements. So this is known as a linked list. That means the list contain the elements. The linked list also contain the elements, each element. But one element know who is my next element. This element know who is the my next element. Okay. So this is known as a linked list data structures are the data structure that support non-contiguous memory allocation. In the case of array, we are allocating memory in the contiguous, yeah, biggest chunks of block. Okay, so let us you say I am going to allocate uh, 15 element. So we need a contiguous 50 element block here. Okay, and again need a 15 memory. Now there is no 50 uh, elements block available, then we cannot allocate memory. But here, some space available. This space can be utilized by the linked list. You can say linked list is the memory utilization. They are not need the contiguous memory allocation. So let's talk how we can implement this linked list data structure in the Python. So linked list is also the fundamental data structure in the Python. Okay, and similarly, linked list also store elements in nodes. So now here the new terminology understand is a node. Previously in the list, we just create the list and storing the element, storing our data, storing our data right now, storing our element, storing. But here in a linked list, we required the each element know who is the my next element. So this element know, hey, this is the element which is the my next element would be. Okay, so somehow here required something. One is the element itself. One should be the address for the, yeah, pointer for the my next element. So due to those, uh, you can say, place this two value. One is the element. One is the address of the next element. That is combined entity known as your node. So where the nodes are linked together. So in the linked list, we are talking the node, one node, another node, another node, another node. Okay, and these nodes are linked to each other. This is known as a linked list, and this is the special terminology. Say node. Node contains the kind of one is the your elements and one is their address for the next element. So let's look. So this is the basic structures of your linked list. So each node contains the data and a pointer. So here in the linked list, if you are going to create any node, that node required the two part, one part holding your element itself, another part your pointer or address of the next node, maybe next node here. Okay, the they contain the address of this block. If another node somewhere, so this know the address of this node. So this is the way linked list maintain. The data store the actual value, and next here, next means reference or pointer to the next node in the sequence. So look like this is your data and next. This node linked to the next node, next node, next node, and the last node would be the null or nothing. So this is the basic uh, structure, or you can say concept, the linked list. Okay, so let's talk what the, let's talk the structures, how uh, we are going to write the linked list node. So each element in the linked list, it is a node. So here we can define the node. So whenever you are going to start the linked list, first you have to define your node structures. Node contain the two parts. One is your data part and one is your next part. Okay. So first time you create one elements, and this is the contain your data and what is the my next pointer, yeah, next reference. Next, if next, else none. None means keep, there is no any next element. So let's look the coding part. So how can define the node? First we define the class class node. A node we have a like a, this is the node. So we can define class node. Node contain your whatever the elements. Okay. So node contains your elements and your, so this is the basic structures of node. Whenever we are going to create links list, first you define the node. So now we define our node. This is the node class, and node class contain the two parts. One part show element, a second part your what is the my list. So this is the concept, and here our node. So how we are going to make this linked list is very we are going to very simplified way to implement this linked list. So here we are going to create this multiple nodes, okay, multiple nodes with the same object. So now this nodes made, and we are going to make a relationship node link between the them, link between them. So now to implement the complete linked list, we have a couple of operations. What the linked list operation? First, you are going to create linked list. Means you are going to create linked list. Second, maybe you are going to the put data, add data. Maybe you are going to the uh, read the linked list, traverse the linked list. Maybe you can delete some element, maybe add element at a first, add element at a last. So these kind of operations we are going to learn how we can do. So here let's the concept I am going to talk here. So here our logics are this. First we are going to create a two node, one your header node, another is your tail node. So whenever you have a linked list, so our header always point to the first element, then next element, then next element, then next element, then next element. Tails node point to the always the last node. So we are going to create the linked list. Linked list also going to create a linked list object that's hold this two pointer. One is your header pointer from where our linked list start, and one more pointer we are going to store, which is the my last node. Okay, so that we can perform linked list operation very easily. Okay, let's do. So here we are going to write a class. Let's okay, maybe linked list. Okay, we are going to create linked list, and here we are going to initialize definition head head and one more element self dot. So here I am going to make a two concept. Our linked list class contain head node and tail. There are two pointer which they are known. What are the my head? What are the my list? So we are going to create two pointers. And now we are going to create couple of function. This linked list support maybe add element, maybe get element, maybe all of other options. So first we are going to define, let's a method add element. Okay, okay. So we are going to define add element. So add element. Okay. So here the logic we are going to build. Whatever the first node, whenever add method say, I am going to create one node. I am going to create the my new node. Whatever the element I pass, let's say I pass the 5. So we are going to create one node. This is the node already we have defined. This node required the element. I pass the element, one node I created with this element 5. Okay, and now we have to decide whenever I'm going to add element in the linked list, we know, hey, this is the first node, first element. If this is the first element, that's this become my header, this become my header as well as, and this is the become my tail as well as. So here say if check, our head is null, our head is none means ki our there is a no any element first time, then you can say, hey, head point to this new node, tail point to this. Okay, so let's say Again I call this add element method and I add one more element. So one new elements come. Let's like a 7. We put the 7 here. So now again check head is null. No, head pointing to this first element. Okay, then we are not going to do anything because head already pointing to the first element. I have created the new element. That means our whatever the this is the tail. What is the tail? Tail also this. So it says tail dot next. I send a whatever the tail dot next. I associate this new number. And now say ki now now this is my tail. This is the first node. This is my second. Let someone call another this new node. So again I call another node like a let's a 8. Okay. Again head is not null because head pointing to the first element. Where is the tail? Tail pointing to the this element. I can say whatever the tail dot next point to this here, and now this is not a tail. Now this is the tail. So if this is the way you can make a linked list. Very simplest way. You are just help of this head and tail. You are ensuring that first node created. Once first node created, you mark this is the my head node and the same node is the tail node. Whenever new element come here, new element you say, hey, this is the my tail, link them, and now not a, now this become a tail. This is the become a tail. Next element come, okay. Whatever the next dot link here, now this is not tail, this is the tail. So this is the code we are saying, hey, whatever the next tail, link them and now make the new node as a tail. So always the new node, this is the your tail part and this is your head part. So let's how to let's this node created. Let's this is node created. This is the node created. This is the node created. This is the node created. So let's see. I want to get them, traverse them. So first we need a head. We need a head. We start from head. We head. Print the element. Go to the nest. 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 Nothing. Stop. This is the sequence that we can traverse to the list. Here display the linked list element. So let's like another function. Okay, display the element. Okay, so what we are seeing display, just write the display. So they are going to display what display. First start the current head point head. If this is the not null, then just print them current elements and just mark this next and pointing to them. So this is the way. Once this loop done, then print none. That is the we reach the last element. So this is the way we can perform the display. So what we are doing display, just starting from head and printing the head element and again say current to next. Notice why we are using the another variable. So let's again. So this is the linked list created. Let's linked list created. Linked list created. This is your head and this is your tail. Right now. So now I want to traverse every element. So I start from head. This is my head. So I just stick another variable current. This current variable pointing to the head. We are just printing the whatever the head element, current element. I am printing whatever the element. Now I say current equal to current next. What is the next of this? Now current become a here. Now print this element. Now again say current equal to next current. Now current point to the here. Q print this next element. Again say current equal to next. Pointing to the next here. This variable you are going to the change next and printing here. And after that, again next, now it's become a none, not null. This is the none. That means it is a stop. Just stop the loop and go print the null. So here we cannot modify head, because if we move head go to the last point and we lose our header pointer. So our header always pointing to first element of the linked list, so that other operation whatever we are going to do we can easily perform. So let's test them. So just create the linked linked list. Let's add element. Let's add element 5, 10, 15, and let's do this. So whenever you add element 5, 10, 15, and if you call hey, that's display, they are going to display 10, 5, 15. In this way, we are making the relationship. So what here we are doing, be carefully. Again, one time more. Here say we create the one linked list. Here we create the linked list object. We created one linked list object. Linked list object. So notice this linked list have a two. We have a two pointer. One is the head. One is the tail. We have a two pointer. So I say add element. We call this method add element and pipe the 5. So one will receive 5. Here's a new node. So I can just created the new node element. This element 5. This element 5. You can say self dot head. Whatever this is the linked list object. This is my linked list object. This is the linked list object, and you can say head is none. Head is none. Yes, head is none. Then you can say head pointing to this new node, and this is the only first element. So tail also pointing to the first node. Now they are not going to us. Method is finished. You can call another method add element. So again call to the add element. So here say again create the new node. New node they are created. Put the value 10. Put the value 10. Can't say head is null. No, head is not a null. Head is null. No, head is not null. Then go to the else. Whatever the tail dot next. What is the tail? Tail pointing to this node. So this node dot next this pointing to the new node. Pointing to the new node, and say tail become a new node. Now this tail pointing to this, and now this is the close, right? And again create another element 15. 15 go to that here, create the another node 15. Okay, head is null. No, head is pointing to the first element. Go to tail dot next. Tail is pointing to the currently here. What is the next? This is the next. Just link to the new node. This is the new node. And tail become a new node. Just drop them, and you can say hey, this is the new tail. So our linked list object have a two pointer, head or tail. Head pointing to the first element and tail pointing to the last element. Similarly, you can add more element. More elements are going to the head here, like 20. Okay. So now they are make a tail to the next, and now this tail become a, this is the now list. So our this linked list object which I created, this linked list object always header point to the first element, tail pointing to the last element. Okay, so this is the way we can add element and display. So let's I want to add element at the first. So let's going to add one more. This let's assume the linked list already created. So this list let's already created here. This list already created. Okay, and now we have a linked list object. Okay, this is the linked list header pointing to the this node and tail pointing to the this node. So this is the linked list already created. Now I am going to add the element at a first. I want to in this linked list I want to create another node that would be the first element. So I am going to create one new node here and say, hey, whatever the header, now header become a this header, and now the header this new node dot next become a your this node, so that this become a first and similar. So sometimes someone say you can add element at first. So let's write the code. Definition add add element at start. So here same thing, you can create one node and check header is none. If there is no linked list, that will go first, and if this is the first node, then you can say node dot next equal to head, and head become a first. So let's say check linked list dot add element. So let's add element at the 99 and start this. So notice here we are, this is the existing element. I can edit the first element. So you can say first or last. By default, the add element is going to add element at the last. So this is the way you can add element. Maybe you are going to add element at the particular position. Hey, so scenario like this. We have a existing list created. Okay. Now someone said this is a 0 position, 1 position, 2 position, 3 position, 4 position. I want to add element at this second position. So I am going to create new node. I am checking whatever their previous node, they are going to the pointing to this new node, and this is the next. They are pointing to the this node. So now traversing the first, second, then this become next, then next, then next, then. So this is the way you can make a add a method that add element at the a specific point. So let's clean it, and let's add one more method like define. Let's add element the at a specific at a specific position. Okay. So you are going to, hey, this is the element. I am going to add the specific position. The first we create the node. If node position, someone says 0 position, that means this is the header part. So we are going to make the new header. Okay, and just return. If this is the else, you can say just loop the position and make the current node is the here. What we are doing first, in the case of first position, else you can start, go to the specific position, you can maintain the current, whatever the current you find, the next make them, and also if the next node is done, then also change the node. So here say let's linked list dot add element at a specific position. Let's create a second position. We are going to add a 2 display. So here notice this is my linked list. 0, 1, 2. 2 position previously 10. Now I can say at the 2 positions I want to add this the 7. So now 2 position it's become a 0, 1, 2 position is 7, 6. So now it's I want to at the 4th position or 3rd position. Third position, let's keep Control Z. Let's okay. So here you want to add that 0 position. So yeah, they are going to add the element at the first position. You are going to add the first position. So this is the way sometime you want to add the element at a specific positions, whatever. But this code, this one just solve your if position 0. Just make the header and return. Okay, there nothing else. But if not the 0 position, first, second, third, then again start from your header and just here till the number you can find the next, and if something you pass the position outside of the range, then they will say, hey, a position out of bound. Let's if you test and you pass something like 20, if there is not 20 position found, they show through exception, hey, right now positions is out of bound. We have to ensure that whenever you are passing the position, you have to check. So due to that, we are here check. Hey, if the current positions is the go to the out of bound, that means here what we did here. This is the this is the next key. This is the node 3 node already created. Okay, so we can say, hey, this is the header part. We can say, hey, current dot header. This is the become my current, and if current is none, no current, not none, then go to the current dot next. Current become a this one. Again say current is not no. Then again current become a nest. Current become nest. Again say is not none no. Then say current dot next. Current become a none. Current become a none. But still say hey current num. Yes. This means you are something looking that's a not in English. So due to that you say ki make a just loop till your position management. And once you found, let's in the case this scenario, this scenario, this scenario. 0 position, 1 position, 2 position, 3 position. Let's add a second position. You want to add element. So this is the our current. This is the current pointing to the header. Current is pointing to the header. Next element 0 time. Next time 1. Second time 2. We are found the second position data. So can say, hey, current dot node equal to current dot s. So whatever the node I going to create it, say whatever the new node dot next, whatever the new node I created here, we are going to the fetch the whatever the next of the current. This is the current 2 dot next. Okay, so here they are going to the pointing to the 2 right now next. Here the current dot next, this become a this new. So in this way we are make a relationship from here -1 position, say -1, that means go to the here between that. Okay. So here we are starting till 1 position. If you have position 2, that means this is the my current position 2. Okay, here 2 and next current node dot next become a new node, and a new node dot next become a this. This is the way make a link between that. Okay, so let me one more things. We have to search element maybe from here. So let us, I want to search the particular element. So let us define definition search element. Okay, so how to know the particular elements found or not found? So simple logic. So whatever the your linked list have, whatever the linked list have, this is your header part, this is the header part, and you can start from header. You can say, hey, this is my current variable, start header, and check header element match with the element. If match, then return it's a found. Right now, if not match, then current become a move to the next. Again check this element found with this, no, then move to the next. Its element match, Is match, return true. Not match, then go to the next. It is match. Yes. So in this way, we are traverse each and every node and matching with the element. If any element match, we return true. Else say, hey, node is not. So let's check present or not. Okay. So notice true. 10 is the true because 10 in the here found. 20, 20 is the not found in this list, then say this is false. This is where you can maybe remove, you can say search the element. Sometime maybe you want to delete some node from the list. Then what? So scenario like this is the created linked list. You have already created linked list. Let's see, I want to remove uh, delete the particular value. Let's this value I want to delete. So I have to found this value and delete the node and make how to delete. Just whatever the previous one, just link them here. So this node is automatic deleted. So previously our wrote this, this, and this. Now this, then become a this, then become this. So this node is going to delete it. So sometime you want to delete some element from the linked list, we can do. So that's a right. Okay, delete element. Okay. Hmm. So this is the deleting the node. So delete node simply if sometime you want to delete head, simply say if head is null, fall, else we can say hey node is deleted. Okay, this is the remove delete element. Okay, this is the way you can deleting the elements. The first you check your head is null, you cannot do everything. If first element you want to match, then we can delete the first element and now your new element become your head. Else just start from the your check and which match. First is match, second match, which match, just skip the one though. So whatever the previous one, notice the next dot next. The previously we are storing and just previously stored say the current node. So let's remove element and check. So notice here we are going to remove element 7. This is your element found 7 and we remove the 7. Let's keep on to maybe remove the first element 3. Make it to 3. So third deleted, first deleted and your deleted. Let's delete the 5. So this way any element you can delete. So in the linked list lots of operations you can made. Okay, so these are let's you play other lots of delete particular position wise, delete value wise, search value wise, lots of permutation combination you can perform this linked list object. So here we discuss whatever we discuss same thing here mentioned simply to creating the linked list you just create the node and make a relationship between the manually you can also make a relationship. Okay, so similarly how to traverse the linked list means how we can read the element again if our linked list is already created, linked list is already created, you want to traverse them, so this is your header part. You can say hey this is the my current variable, start with header, this is the header, and if you check header match, print header, header print, then go to the next. This is the current equal to current next, that means now current pointing to here, Now current pointing to the here. Again loop and print them. Again next, print them. Again next, print them. This is the way you are getting the value printed. Similarly, how to insert elements at the beginning. So if already this is the some linked list already created here, linked list already created here. This is your header. This is your tail. Someone say insert at the beginning, first position, right now. So you just create a new node, create a new node, and you can say whatever the header part. So this new node dot nest become a your header. Okay, become header, and now whatever the header now become a this header. So the so our link node started from this is the header one, then this, then this, then this, then next. So this is the way sometime you can add the new element at the list. Similarly, maybe at the end. So simply go to the last and add the new. Okay, very at the end, very simplest way at the end. If we have a only one header pointer, two approach to implement. If we have a only one header pointer, let's say I want to add here new element. So I have to go first here, then now next node I can link it. If you have a two pointer, one is the header, one is the tail. Let's tell. I want to go to the at the end. I can just create the new node and from tail to point here. So you have to avoid the traversing if we have a tail pointer. So this approach where we have only one header pointer, you start from header, go to the next, go to the next, go to the next. At the last, whenever you go to the last new node here, you can return. Okay. So if here we have add element. This is the always go to that our last element. Now, whenever you're going to add the element, this is the first or this is the last. In the case last, we just tell that next equal to new node and new nodes are added. Similarly, maybe delete elements by value. So, if we have already linked list created, the linked list created. Okay, if you are going to delete a specific value, you just start with your current pointer. This is the first. Check match the element, no. Go to the next, match the element, no. Go to the next. If this element match, how to delete? Whatever this node, I just move to the so here. You can say if the next data match key, just change the pointer. Okay, so this is the way you are going to delete a specific element. Similarly, you want to searching some elements, found or not found. Same way, just like traversing the list, whatever the linked list we have, whatever the linked list we have, let's say I want to find the particular key. They start from header. This is the current. This is my header. We start from header, and we can current. If data match with this key. If match, you can say it's found. Not match, current go to the next. Go to the here. Again, loop here. Make key match. No. Go to the next. If key match, return true. Else go to the next. If key match, go to the rest. In this way, you can traverse the linked list and find the particular elements in the linked list or not. So whatever the till now understand that as the known as a very basic linked list and sometime known as a singly linked list. But till now, whatever you discuss, this is known as a singly linked list. But a couple of more types of linked list also exist in the list. You can say type of link, singly linked list, doubly linked list, and circular linked list. So each here, let's talk about three little bit theory. What is the doubly linked list and circular linked list? Till now, whatever we study known as a singly linked list. So as your definition, singly linked list is the simplest kind of linked list. Is take up less space and memory because each node have only one address pointer and the next point. You can say singly linked is the just they have a only data and the next one pointer, one data element, and they are linked to the next. This is the till now we study. This is known as a singly linked list. This key from here you can go to the next, from here you go to next, from here you can go to next. The one way you can see. This is the singly linked list. Let's talk about the doubly linked list. Doubly linked list, your node have a three part. One your element, another next pointer, another previous pointer. So notice this is the my node. Node contain data. What is the my next and what is the previous? So doubly linked list have a approach where our node can have a two pointer. One is your data, one your data, another two pointer that contain the previous node, another pointer contain the next node. They have a previous node, next node. Due to that doubly linked list, the address with the both the previous node as well as next node. So in this way, from here you can go to the move here, go move here, or backward or forward. So here you can move from header to first, let's see your header node. From here you can move to the next node. You can move to the next node. You can move to the next node. If you want, go back again. You can go to the back node. Go to the back node. Again, go to the back node. Header node is the previous is the null. Tail node next is the null. So this is known as a doubly linked list. In the doubly linked list, you can traverse on the one direction, and even you can traverse from the backward direction as well as. So in this case, header previous is the null. Here previous pointer is null. In the tail, previous next pointer is the null. This is known as a doubly linked list, where you can traverse the forward direction or traverse the backward direction. And this is take up more memory, be clear here, because we are adding the two pointers. Sometime another kind of linked list known as a circular linked list. So whatever the you can say the linked list we study, singly linked list and one is the doubly linked list. Okay, doubly linked list. So both can be circular. Circular means, let's see, like this is the my singly linked list. One node point to the next, this node point to the next, this node point to the next. This is your singly linked list. So is it possible that our tail node, this is the header node, tail node can again pointing to the header. Instead of tail next node pointing to the header, now it's become a circular link. So whenever your tail pointing to the header, that become it's a circular linked list. Similarly, maybe doubly linked list also. Whatever the doubly linked list here, whatever the doubly linked list we have, a doubly linked list. This is the next pointer, next pointer, next pointer. This is the previous pointer, previous pointer, previous pointer. They have a previously null. They have a next null. So instead of that, you can say, hey, this is the next would be your header. A previous would be this. So this way become your circular doubly linked list. This means your header previously pointed to the null, but instead null is previous pointed to the your tail node. Right now, our tail previously next is the null. Now next pointing to the head node. So here circular doubly linked list we can create. So as per our use case, as per our situation, Generally, singly linked list is the suit for almost major problem, but sometimes we can also build the doubly linked list. Okay, so these are the couple of operations we already discussed. We can perform. We can search element, traverse elements on the linked list, even the remove element, even to add element, even you can sort the element as well as in the linked list. Okay, so these are some basics about the linked list, and we have to understand linked list support the three kind of linked lists. One is the singly linked list, singly linked list. Second types we understand the doubly linked list, means we have a two node previous and next. Okay, previous node, previous node, previous node. Here previous is the null. Here next is the null. And these two, singly linked list, doubly linked list, can become a circular if you say, hey, this is my header, this is my tail. If tail node pointing to the head node, it's become a circular. Similarly, here say tail node pointing to the header, this is the circular. Similarly, this previous pointing to the this tail node. So now it's become a circular. So sometime you make a singly linked list, doubly linked list, two types of mainly, and in both case you want to make a circular, just make the header know the tail know the head. This is known as a circular linked list. The linked list programming wise is the very simple and good part. Linked list already Python have some inbuilt library we can use. But as a initial, whenever we are learning the Python, we should know how to create the node, how to create the linked list, how we can implement these operations like traverse operation, insert at first, insert at a middle, insert at a delete element by index, delete element by value. All this operation, whenever you are writing code, you feel too much comfortable. Okay. So hope this information is helpful for the linked list. Thank you. Okay.